Okay, so kind of pick up where we left off. I'll go through a few papers at the end of the day. I posted them kind of late. I didn't really expect you to kind of go through all of them. It's more of a central theme that I kind of want to hit on. So I might pull some of them up today, but I might just show you a couple of the tables and kind of regression equations that come from them. So where did we leave off here? So we kind of left off thinking about promotion leagues and thinking about competitive balance. We then kind of talked about, the one issue could be that it's very difficult for teams to rebuild, right? So this idea of rebuilding, really, every team has a decision, and that decision is going to impact competitive balance in any given season and across kind of multiple seasons. So let me get this out of the way here. So, the ultimate goal, obviously, we talk about profit or win maximizing of a lot of teams, or kind of one of the byproducts of profit maximizing or kind of win maximizing may be that a team kind of wins the championship, right? So if that's the ultimate goal, because there's a lot of additional revenue that comes from winning the championship. So, if I'm in a large market, even if I'm profit maximizing, that may be my goal, right? So it comes down to potentially, right, depending on the size market I'm in, and, I'm just choosing numbers here just to give an example, right? You can remain competitive for a much longer time, or you can choose to maybe not be competitive in certain years so that you are kind of ultra high quality every 5 years, right? So I could be very competitive for 10, or I could win a championship every 5 years, and maybe in the in-between years, I have somewhere I'm much lower in quality, right? So we kind of think about this trade-off exists, and right, decisions that teams are making. Although in a lot of these models, we boil them down and we're kind of thinking about them on a season-to-season basis over like a longer time period. I'm trying to maximize, not just over this year, but over the next 50 years, right? Or kind of the way that we typically think about companies is over the indefinite time period, right? So we have this trade-off that exists that was kind of ruled out when we were looking at those promotion leagues, okay? So ultimately, what we're boiling it down to is that if, winning this championship brings in so much additional revenue that even the lost revenue, if I add that up for the 4 years prior to when I win the championship, if the additional revenue is enough to be greater than the sum of those 4 years, then even if I'm profit maximizing, I potentially would choose to kind of go through this rebuilding every so many years. I'm choosing 5 here just as an example. But if the additional revenue is that much greater, that would kind of be optimal for me to do. All right, so that's just kind of briefly touching on what we talked about last class, and thinking a little bit harder that sometimes we're looking at these different issues within a season, right? We may make very different decisions than if we're thinking about making a decision for the next 20, 30, 40, 50 years. Okay? And that potentially it could be optimal to be worse this season to have future potential gains. Okay? So we're then going to take kind of a little bit different kind of route here. We're kind of got to move away, I wouldn't say completely from competitive balance, but something that's kind of related, but more of like an individual sport. Okay, so if we think about wages or wages that exist from different tournaments, and we'll typically, the examples we're going to work through now, we'll just think about these as winner take all. We could complicate them, and there's different payoffs for the top 20 players, but for now we're going to think about a winner take all scenario. So this would be something like, I don't know, in a golf, it's not called a match. What is it called? I don't know, whatever. Right? We have one golf tournament or event, right? That if only the top player there, the top golfer, gets the overall kind of winnings or prize, what would that look like? And like I said, we could complicate it so that the second place would get some and the third place would get some. But for right now, we'll just think about a winner-take-all tournament where whoever wins gets the entire sum of all the prize money that's available. Okay? So if that's the case, right, it's not necessarily based off your absolute performance, right? It doesn't matter. It's not tied directly to how you perform in that tournament. The winnings are actually tied to your relative performance. Right? Were you the best on that day? Not were you the best ever, not was your performance high, but just was it higher than everybody else's, right? You can look at lower level tournaments or maybe amateur level tournaments where, yeah, your performance isn't the best overall, but it was the best on that day for the people that participated, Okay. So we're thinking about relative performance now. Okay. Whoops. And we think about that, basically utility increases with income, which is pretty standard. We also think that utility increases with the amount of leisure I can take, and that any effort is going to be costly to me, right? So if we think about this idea that effort is costly, or there's going to be some cost to the effort I put into this tournament, right? We can start to think about the differences that might exist in optimal effort. Now, competitive balance, across a golf tournament is a little bit harder to think about than just the competitive balance in a league. So I won't kind of push it that far, but you can imagine that if we have different optimal effort levels for different players in these tournaments, that's going to create different, competitive balance or parity within those tournaments as well. Okay? So this optimal effort choice that we're thinking about is going to be wherever that marginal cost of effort, right? Effort is costly, is equal to the marginal revenue of effort. So we'll simplify it down quite a bit to start out, and I'll kind of show you a model that would make it a little more complicated. So what we're going to think about the marginal revenue of effort, if it's a winner-take-all tournament, the only revenue I can earn is whatever the value of that prize is. Okay? So, oops, let me see. I want to go switch this. Screen, there we go. Got new markers today too, so hopefully these show up a little bit better. There we go. So the kind of simplistic model that we're thinking about and we could measure effort in a lot of different ways. You can think about, we'll have some unit of effort, right? And that it may be that for players at different quality, right, to put in that same level of effort may take a higher number of additional hours. Right? So whatever the kind of measure of effort we have is, we can think about we're going to have increasing marginal costs, right? If it's easier to think about, just like practicing, right? The first hour of practice will be using an hour where I didn't have any other additional high opportunity costs. There wasn't a lot of other things I'd rather do at that hour. But once I put 1 hour in to put the second hour in, well, now I have to choose another hour out of my week or whatever to, that I value a little bit more. And then eventually, once I get to practicing for 60 hours, right? Well, now, if I put in a 61st hour, I might not be able to kind of also go, I don't know, take care of my kids, or we can go to a real extreme once we get to 60 hours a week. And so we would think about as effort is cost, increasing in cost, right? The marginal cost of effort is increasing. A little bit unique is that if I think about the marginal revenue of effort, right? If I win, it doesn't, regardless of how much effort I put in, if I win this tournament, I get kind of all of the prize money, right? So we kind of think about, we've got dollars up here on our y-axis. So whatever the value of the prize is for that tournament, that's going to be our marginal revenue, because it doesn't depend on effort, right? In the sense that if I win, it doesn't matter if I practice for 5 hours or 20 hours, I still get the same amount of additional revenue, right? So where's our optimal effort point going to be? Well, just like in almost every kind of market or model we look at in economics, we really can translate everything down to marginal costs and marginal benefits. Here, marginal benefits we're calling marginal revenue. Kind of think about, here's our optimal effort point. So this might seem rather intuitive, but at least now we can have a visual and a model to understand it. What happens if the prize money for a tournament was lower? Well, that marginal revenue would be lower, right? And then the optimal effort choice, well, if there's less prize money available, I'm going to put in less effort. That's a fairly intuitive result, but just thinking about these winner-take-all models, you can kind of reproduce that result, right? Based off of the marginal revenue and the marginal cost. Okay? So offering higher levels of prize money is going to increase the optimal effort that someone's going to put in. I said the easiest way to think about that is hours of practice, but it really is some measure of, we're not measuring hours necessarily here. It's how maybe psychic, like the psychic costs, right? How mentally draining it may be just to think about kind of this sport or kind of your performance as you're in the tournament. But it's easy to probably think about this as a number of hours. Right? Shouldn't be too bad. Any questions on that? So what if, and this is a little bit, I got everything, I got multiple things on this graph, so I may want to redraw this. We're okay with this? Okay. So let's think about a similar model, and this way I kind of draw this kind of quickly. So we've got effort, think about some marginal revenue. We've got this increasing marginal cost. Call this E1. Okay. So if we think about players of higher, well, what's the best way to explain this? If I have higher quality, okay. So if I have someone who is of higher quality, right, or higher ability, perhaps the marginal cost of them is going to be a little bit different, right? If I'm of higher quality, right, I could put in the same amount of effort as you, but it may be less costly to me. So I said it's okay to think about effort as hours, but if I'm putting a certain amount of effort in, it's going to require me, right, a lot more hours than it is, using this example sense of recent events, but Tiger Woods is going to put in a lot fewer hours to get just as good at golf as I would have to, right? So the sense for him to put in the same level of effort to win the tournament, it's going to be much less costly to him, right? Because he's going to have to put in fewer hours, right? So the same level of effort that would be required to win the tournament, well, he needs to put in far fewer hours to kind of reach that level. So you can almost think about it as if we have a higher quality, maybe I'll call this HQ. I'm going to call this low quality player. Right? That higher quality player, at each level of effort, the costs are much lower. Right? At each level of effort, the costs are much lower. And kind of similar, I think we talked about this a little bit when we talked about the Tiger Woods player or paper. The idea would be that high quality player actually ends up choosing a higher level of optimal effort necessarily. Like if I'm a very low quality, potentially I don't put as much effort in. It's not quite the same thing we're talking about. We're talking more of a competitiveness from that paper. But a very kind of similar idea is going to point to that potentially these higher quality players end up putting in more effort. Right? Because it's less costly to them. Right? Or another way you could think about effort being less costly if you don't want to think about the number of hours. If we go out and put the same number of hours in, let's say I go, Tiger Woods goes and golfs for 10 hours in a week. He's probably going to enjoy that because he's good at it. It's not hard for him to kind of do well. The psychic costs, like frustration, like if we're measuring this kind of disutility, very low to him. If I go out and play golf for 20 hours, I'm going to be frustrated as hell because I'm not good and I'm going to be mad every single time I make a mistake. And so that's another way of thinking about these higher kind of psychic costs that exist. Any questions on this before we kind of keep pushing it? Okay, so I'll leave that up there as I kind of return to what we're talking about here. So what's some of the evidence, right? Do we actually see that this exists, or we saw higher quality players and putting in more effort, or that when prize money is higher, we also see more effort put in? Like that was kind of what our models would predict. So there's a couple interesting findings that we'll mention here. So, these two authors found that for the final round of golf, so they looked at the final round of golf and we're able to, determine kind of who is even in the running for winning the prize, right? I don't want to look at everyone, but I just want to look at the individuals who had an actual chance of winning, right? They were within a certain amount of, I forget what their cutoff was, but within a certain kind of distance to that top score. So what they found was the higher the total prize money, they actually saw lower golf scores, which that's a good thing, right? They saw performance increase, which we don't ever usually have a measure of pure effort, but as you increase effort, that should be reflected in your performance, right? So they found that higher prize money led to kind of lower scores or higher performance, indicating higher effort. And they also found the greater the gap in between prizes, kind of the lower the scores were. So when I think about gap in between, all the models we just looked at, we thought of it as a winner take all. If instead we had, there's like a first and a second place prize, they found that the greater the gap between that first and second place prize, the lower the score. So the idea there is, well, now it's much more beneficial to be first than second if that gap grows, right? You gotta think about it. Let's say first prize is $1 million, and then the second prize is also $1 million. How much additional effort am I gonna put in to go from first to second? Let's assume we have 2 people. Well, I'm just gonna play. If I end up getting second, that's great, I get $1 million. If I end up doing better and winning, I get $1 million. But as that gap grows, maybe, you know, first place prize gets $1 million, second place only gets 100,000. Well, now there's a huge additional incentive for me to put in more effort to win that tournament. Right? And to kind of equate that to what we were talking about, I started out with a winner take all, explaining those models. Let me pull one of those back up. What you actually could think about, this is the one I want. I have to knock something over there. Instead of thinking about the marginal revenue as the prize money, once you introduce a second place prize, what's the marginal revenue? Well, then the marginal revenue essentially just becomes kind of the difference between the first prize and the second prize, right? That's the additional revenue from winning that tournament, right? As opposed to getting second and getting kind of the second place prize. So that's why, you know, the intuitive kind of result, when I said the first and second place prize are the same, what's marginal revenue of winning that tournament become? 0, which means that I'd have a marginal revenue down here at 0. Where does that hit marginal cost? Well, here it doesn't even hit marginal cost, so the effort would be 0 effort. And that was kind of the intuitive result, but we'd see the same thing if we try to reflect that in the model. So the only difference is the prize money becomes the difference in prize money when we have 2 prizes. Okay. All right. We've already kind of talked about this paper, where there may also be some additional impacts of how, you know, likely I am to win the tournament, right? And I'll try to build that into a model that I won't expect you to like ever reproduce, but I want to kind of push it and show you what maybe a more realistic setting would look like if we're trying to build in, right? Our models, we start simplistic and we just continue to build more complexities in them. So we've already kind of discussed this. And there's also this really interesting paper with the idea of kind of relative ability or performance, which is that, I think this is, I think it was in Israel. They did this study, but they took a bunch of 4th grade students, and they first started out is they had them run alone, right? So, you know, had a bunch of 4th graders say, look, we're going to run, I don't remember exactly what it was, you know, 40 yards or something, right? Maybe shorter than that. They're only in 4th grade, but we're going to have them run 40 yards and we're going to see how long it takes them to do that, right? And, you know, we're dealing with 4th graders, so some of them, you know, hell, some of them stop and start picking dandelions and then get back. You know, they're just kind of running as fast as they can or as fast as they want to, right? They then ran, so they clocked their times. They then ran those students against other students in their classroom. So now they're going to run in pairs. So now they have someone that essentially and there's no prizes other than you win the race. Like, they're not giving the kids any money or candy for winning. They're just saying, all right, you're going to go, you know, run against Johnny now, and we're going to, you know, write down who wins. And what they found is when those students ran in pairs, relative to the time when they just ran on their own, that the boys in that group actually ran faster, right? And that the girls actually tend to run slower, right? So this is in a line of research that starts to look at gender differences, and we can start to look at things like competitiveness, but also the desire for equality, right? So, you know, the authors, I think they make a little bit of a stretch. These are 4th graders, and, you know, how controlled can this be? But what they equate this from, they relate it to some lab experiments they did, not with running, but with some actual economic experiments, that potentially kind of there's something in boys, whether or not this is social, that has more of a drive or more of a utility gained from winning, as opposed to there's a lot of economic experience that kind of match up with this result, which is that females tend to value or get a higher utility from equality, right? Equality in outcome, okay? And so this was kind of what, you know, they related to this. So there might be some other things going on as well when we're looking at this effort choice, right? Now, this had no money tied to it, I think when you're talking about golf prizes that are in the $1 million, we maybe all derive utility more from income than equality in those situations, right? But just some kind of interesting kind of findings, and this is kind of the idea of a tournament, right? There's two people, one person wins, one person loses, okay? So in these same models, we can also start to think about, and it's similar to this high quality, low quality idea, but that instead of effort, we can actually cheat, right? And how does this look in sport? Well, we typically might think about this as using PEDs, right? I guess there's all types of cheating, but I would think the most common that we see is blatant, although, what was it? The Astros, is it 2 years ago now? Got caught kind of doing so. So there's always kind of examples of cheating. We can think about it. I'll use the idea of using performance enhancing drugs or steroids as kind of the example. So if I'm using performance enhancing drugs, right, you can think about if I'm trying to even, actually when I think about this, I think it's the easiest one for me, but it's because I somewhat have like a knowledge of it. So if you think about like powerlifting or something where you're purely going for strength, right, I actually can put in fewer hours of work to get the same results, right? So that's the exact same idea as quality, right? I said Tiger Woods can put in fewer hours of work to get to the same level of effort required to win a tournament than I could, right? Someone taking performance enhancing drugs has to put in fewer hours of work to achieve the same kind of result as someone who's not. And so the idea is that effort, you're really just reducing the cost by cheating or using these performance enhancing drugs. So what would that maybe kind of predict? Well, really then using performance enhancing drugs is actually just increasing quality, which actually is going to predict we maybe see higher levels of effort, right? Because now, they're not just going to put 10 hours in, they're going to put maybe the same 20, but that's going to equate to a much higher level of performance, right? Or that those first 10 hours spent are now much easier for them, in the gym, lifting weights, whatever they're doing. And so the cost of each hour, the cost of that effort is going to be much lower to that person who's on performance enhancing drugs or cheating. So really, the model of cheating here, it's really just the same idea as going from low to high quality. It's going to reduce the cost to that effort. Okay, so we'll equate that to that. So that's all I kind of, like I said, we could basically draw this exact same model and replace high and low quality here with non-performance enhancing drug user and then performance enhancing drug user. So these models allow us to start to think about some of these issues. Any questions on any of this? We'll keep moving here. Okay, yeah, this isn't too bad, I don't think. All right. So this really, this was kind of the last idea of some type of competitive balance or more of like an individual level. Now we're going to switch to thinking about some things that leagues or teams might also care about other than competitive, balance. I had to burp and I caught me mid-sentence there. So if we look around at the different major leagues, even if they don't move locations or move cities, we see a lot of them moving stadiums. In fact, first homework assignment, which I have all graded now, so everyone should have a grade up there on Canvas for that. I haven't taken a look at the total scores, but I'll post an announcement on Canvas because I think I am going to curve it a little bit. I just haven't determined exactly how much yet. So I'll post an announcement, kind of get those grades updated here. Actually, I'll probably do it tomorrow morning. I'll get that up there. I'm also a little more than halfway through of the project proposals, so I've kind of got a response to about half of you. Going back to my office after class today, I'm not going to leave until I kind of get the rest of those done tonight. But one of the things we mentioned in that first homework was kind of moving stadiums, right? Even within the same city. So we see teams build new facilities, and why do they do this, right? Well, these stadiums have huge costs, right? So some of the newer football and baseball stadiums, if you look at the price tag, some of them been over $1 billion, right? This is absurd, right? This is a very high fixed cost, okay? So a couple of those examples, the one that was built in Atlanta was just over $1 billion. And then this one's a little bit, two teams are using it, so they split the cost there, but still it was $1.6 billion. This is wild, like these huge facilities. So what has to be true? What do these teams have to believe if they're spending this much money? What do they also believe is these stadiums or these new facilities might do for them? Yeah, I mean, if they're making any type of a rational decision, they think that revenues are going to go up quite a bit from this as well, right? So, I have a couple more examples, right? The one in Brooklyn was a billion. NHL, we got $500 million here. So high cost, right? So these benefits, they believe that how are they going to get this additional revenue, right? I mean, the main way is, it's not like having a new stadium is probably going to, cause broadcast revenue to go up that much. It's probably not going to cause like apparel sales to go up that much. Maybe a little bit there, you could argue. But really believing that through the ticket revenue is really where you're going to see this return, okay? So you're going to have to believe that you're going to see a boost in attendance or that these new facilities are going to boost demand, right? Which would predict not only increases in attendance, but even if attendance was met, increases in ticket prices, right? So, one thing that's kind of interesting, if we look at the years following most new facilities, we tend to see increases, right? So they believe that it is going to boost attendance or ticket prices, and sure enough, we see that it does. However, right, this effect starts to decline like after years 1 and 2. Okay, so those first 2 years we see a boost, but then after that, yeah, they're a little bit higher, but it kind of starts to trend downward. Right? And that, let me see, I thought I had the exact year from this paper. So there was a paper that looked at this. They were specifically looking at the Orioles and the Indians, and they found that after the first 3 years, right, so initially it went up, and then it started to decline, and after 3 years, there was no difference, and then I think by the time they got to year 5, they actually found that for these two teams, actually had attendance that was lower than prior to their new facilities, right? And now a lot of things impact attendance other than the new facility, right? So there could have been some confounding factors like maybe team quality was trending downward during this time, or maybe there was some income changes in the cities during that time. But they did find that, this is a very short-lived effect, and that potentially these confounding factors kind of, are really what are going to drive attendance more than having a new facility. Okay? So, if we could make enough revenue, if we can make $1 billion in those first few years from additional attendance, then they would still be warranted to build these new facilities. But, if we look at ticket revenue numbers, no one's making $1 billion over kind of a 2-3 year time period. So are these costs really justified? I mean, I guess technically to do a real perfect study, these facilities exist for a very long period of time. So we'd probably have to go out something like 50 years to kind of look at whether, and kind of compare whether or not new facilities over a 20-year time span or a 40-year time span would have higher attendance and higher ticket prices. But a lot of the initial findings we have is that it's probably not justified for these teams to really be spending that much money on these facilities. Now, I think the NFL is a little bit different, or Major League Baseball is a little bit different than, say, NBA or NHL stadiums, because these new facilities aren't usually just used by the team. They're also used for concerts and, I don't know, they do like monster truck rallies, all kinds of stuff, right? And so even if they don't see that this attendance increase is just coming from their team, potentially there's a whole bunch of other markets, the things that they're using these stadiums for, that would also kind of warrant spending these huge amounts of money on these facilities. But if we're just looking at the professional teams, if that field wasn't used for anything else, it wouldn't warrant it. Okay? There's also been some other findings that it is actually the greatest in the Major League Baseball. And then NHL, we see a little bit greater than the NBA, and kind of the lowest effect was on NFL. Right? But then it got some researchers to thinking, why would the effects be so much lower in the NFL when we look at increases in attendance? Right, so we're not looking at revenues here. We're just looking at increases in attendance. Why might the NFL, or some other things that we've talked about, not see as much of a boost in attendance? So, yeah. Yeah, so if we go way back a ways, when we looked at like revenues, and I kind of showed the great disparity in revenue and ticket revenue in the NFL, they currently, this could change over time, but currently are facing, we would think, the highest demand curve for the sport, right? They have, if we compare them to other leagues, they by far and away have some of the highest ticket prices, right? They by far and away tend to sell out their stadiums more than others. Okay? Now, it's not every team, but there's a larger majority of NFL teams that do that as opposed to like NBA teams, okay? So, right, if we're already at capacity, we're not going to see any growth in attendance, right, unless we build the stadium larger. So what we probably want to, be focusing on a little bit more is kind of what's the total revenue that's coming from this, right? But what's the total revenue that we're going to get? And that's going to involve not just attendance, but also ticket prices. This last point is just that if we are able to kind of charge higher ticket prices, or we do see larger attendance, that's also going to increase our marginal revenue per win, right? Because part of that marginal revenue curve, right, it comes from all different sources, but part of it was coming from ticket revenue. So if we can get this boost in attendance or ticket prices, right, then potentially we should see this kind of shift in our marginal revenue curve when we look at that win market as well. Okay? So it's kind of a weird one. I'm not sure I have it. I think, let's see here. I don't think I had it over here. So I want to relate this to something else that we've talked about. I couldn't remember if I had it in the slides or if I just wanted to do it. Here, there we go. So weirdly enough, right, if we did see this increase in revenue from a new facility, not only might we see a boost in attendance or ticket prices, but if I think about the win market, once again, I'm just going to simplify marginal cost here to make it a little bit easier to kind of think about. So before, if we're looking at my old facility, if this facility at all boosts my attendance and ticket prices, that would boost my marginal revenue or consequently the overall demand to attend the games and kind of the demand curve in the win market. So we would see this increase. Oh my God, I draw my lines a little bit further. An increase in the demand and marginal revenue curve from the new stadium, which, if we think about relative to the old stadium, would actually cause, I'll call this W1 and W2. All right? Actually, I don't know why am I not thinking correctly here? Let's just call this old and new. Make it a lot easier, right, with this notation. So one of the consequences, if this does occur, we see this boost in attendance and in ticket prices, we actually think that potentially the quality of those teams could increase as well, right? And you think about it this way, you're not moving to a large market, but you're essentially kind of moving, towards that demand curve that those larger markets face. So I just thought this is interesting. I don't know if I've seen someone break this down, but it would be kind of an interesting thing to look at. When we see these new facilities, are a higher proportion of them small market teams or large market teams? Because if they, if teams do believe this is what's occurring, it would make sense that maybe small market teams will be trying to build new facilities so that they can kind of get closer to those larger market teams. Or, if we see the league, I know they don't do this, but this would be I always thought this would be an interesting tactic for competitive balance. If having a new facility really did lead to this higher demand and marginal revenue curve, and you're thinking about that would be reflected in the win market. So the demand is higher in the ticket market, but that revenue is part of the marginal revenue curve here. What could the league do if they wanted to help support not only the league, but also these smaller market teams when it comes to kind of building new facilities? My brain might be working differently, so it may not be obvious. But let's think about things like subsidies, right? If the league wanted to, they could think about maybe taking some of their money and subsidizing or paying for a proportion of those new facilities. Because now I don't have to rely on the small market teams if I do some revenue sharing. Well, if I just give the team money, they may just pocket it, right? We talked about that. If they're profit maximizing, it may not have any effect. But if I say, look, I'll help you build a new facility, right? I'll cut the cost of the new facility. Well, if that entices those small market teams to build the new facility, even if they're profit maximizing, that would move them to a high number of wins. So like I said, I'm not aware of any league that has even proposed that, But it's an interesting combination of this idea of new facilities impacts on teams and maybe what the league could do to kind of help reduce competitive balance. Or another thing that I haven't gotten completely through all the projects, but another one that could be interesting, and like I said, if you ever do want to kind of like switch, especially this early on, that's okay. Let me know. But another thing would be, do we see when new facilities are built, do we see improvement in competitive balance in those first few years after a facility is built? Because this would predict that maybe we should, especially if those new facilities are coming from a small market, or conversely, if it's large market teams that have the new facilities, maybe we see a competitive balance decrease. All right. So some teams don't see this boost, even if we account for the fact that they're already like at capacity. So if we account for capacity, so what a lot of papers will do is instead of looking just at attendance, right? Because attendance, can get maxed out. But also look at total ticket revenue or even percent of the stadium that's filled. Well, the reason why, even if we account for those things, we still might not see this boost is performance still matters, right? If I build a new facility but my team is terrible, right, I'm still not going to see a high enough increase in my demand curve that no one's thinking about this, right? No one's going to come to the games, right? Even if the new facilities shift that demand curve up a little bit, my poor quality decreases it back down. I'm not going to get a boost in demand. So, new stadiums can't kind of overcome kind of this significantly high losses, right, or significantly kind of poor performance. And so then when we go to the actual data, this is one of the problems. When we look at these linear regression results, we have to take them all with a grain of salt and remember they're just evidence of a correlation, right? And it may be something that's kind of outside factor we're not accounting for is really what's driving the results. So, and that's why we try to include as many controls on that right-hand side as possible of our regression equations. But it could be that if we use an indicator for whether or not a new facility was built, and then we look at like the team's performance that following year, well, maybe it'll look like it has a negative impact, but that was because the teams that were performing poorly believe that building a new facility would help them improve, right? And so it could just be that building a new facility is more of an indicator that a team has already been previously performing poorly, right? So it could be kind of correlated with that quality. So if we don't account for that or we don't control for that, that would be an issue. Right? So anytime we kind of look at these studies trying to look at the impacts of new facilities, they should be also trying to control for the quality of the team prior to when they decide to build that new facility as well. So New York Yankees are kind of one example of this when they had all their big renovations. I forget how many years ago this was now. Not too far in the distant past. They actually saw attendance decline the following year. So not only may it be that they weren't performing as high, the performance wasn't as high quality as it typically was, like New York might have some high standards. But also, this is another example of a stadium that if we have these old stadiums and they start to kind of change them too much, potentially see a decrease in the demand because fans kind of have some utility that's derived from, I guess I'll use the word nostalgia, but like kind of this historical stadium. But they did see revenues increase. So even though attendance declined, part of that could be their pricing strategies. They ended up kind of increasing ticket prices quite a bit. And, $100 million in the first year, right? If I can continue that trend for the next 10 years, I've made up for that price of the renovation, okay? Or cost of the renovations, I should say. All right, I think I have. We've already talked about this, kind of these ticket prices. I've already really kind of hit this, pretty hard already with these examples. But another thing with these new facilities that we might want to take into consideration, even if we see attendance fall, like in the Yankees case, even if we can increase ticket prices, and so that's what was driving this additional increase in revenue, even though attendance was lower. What also could be driving that lower attendance is a lot of these new facilities have a higher ratio or proportion of seats that are luxury suites or boxes. And so, if I get rid of 100 seats, that, I don't know, the ticket price was, $20, but I can build a new box, and, the price to rent out that box is, I don't know, something like 20,000. I'm making up numbers to make sure, really exaggerate that point. But the fact is that if you can derive more money from that luxury box than the seats that you lose out on by having that, then that's okay. It makes more sense, right? You'll see lower attendance, but the overall revenue you earn will be higher. So that's one thing when we look at these new facilities. They all tend to have a higher proportion than they did before of luxury boxes, or what I say, club seats here, like whoever you want to think about them as. So if we just look at some of the more kind of recent NFL, there was kind of a trend going where these newer kind of stadiums, we start to see kind of have some higher numbers, and then the kind of LA Coliseum, maybe we see a dip, but maybe they realized that it wasn't really the luxury suites that were the highest revenue earner, that if they create these club seats, they can get a lot more of them and still have a significantly higher ticket price than for their general seating. So we see them trying all different types of strategies, but the idea is they're trying to move to where they're creating differentiated products, right? They have some seats that are going to be have a higher demand from the consumer than their general seating, and so they know they can charge higher ticket prices. So if I lose out a little bit on attendance, that's okay, because I more than make up for it by this difference in the prices for these club seats and kind of a regular seat. Okay. Any questions here before we move? Yeah.
So with some stadiums, would they have more suites depending on where they're located as far as income base? Because if the city has higher income, it's more room.
Yeah, so if we go back, I don't remember how many weeks now, we did talk about these luxury boxes or these suites. And what was the one city, does anyone remember, that we said had the most? And I think this was, we might have been looking at baseball, Major League Baseball instead of the NFL, but the same kind of thing I'm sure applies. What city had the most luxury suites? Yeah, it was San Francisco, and we said why? Silicon Valley, right? We've got nearby, and we've got a lot of huge companies that typically buy out these suites. So if for sure that each of these stadiums, they're going to build for their consumer base, right? And so if their consumer base for these higher end seats are as companies, maybe in I was trying to see if they built a new stadium if they were on the list, but they're not. Maybe in San Francisco, we have a much higher proportion of luxury boxes, and then maybe in a city like, what's a city with Seattle's got a decent amount of industry in it. I was going to say, what if we had a city like Seattle, but they probably don't quite fit it because they still have quite a few companies, but they just had a high income, but not a lot of big companies in the area. Well, they may choose to build fewer luxury suites and more of these club seats. LA, I'm guessing that's why they did that. There's a lot of companies around LA, but probably not as many types of companies who are renting out these luxury suites and boxes. Well, they definitely have a lot of high-income individuals in the city who they think might want to buy these club seats. That's a good question, though. Yeah, well, it definitely was going to be city and team specific.
Do you think that's why so many teams are moving to Vegas? Because I feel like Vegas.
Why would they move? So I don't know off the top of my head, but my guesses would be there's a couple reasons that we've talked about why teams might be more likely to move to Vegas. Prior to the last 5 years, if we go, when did the NHL team start there? Less than 5 years ago? Yeah, so let's say we went back to 2010. Why might Las Vegas be an attractive city to move my team to in any league? I might have to have a little more sports knowledge to know the answer. But in 2010, there was no team there, right? There's no NFL team. There's no Major League Baseball team. There's no NHL team. Well, sorry, that's right? The NHL team, yeah, 2010. And there was no NBA team. So you literally have no competition in that city, right? So that's one of your reasons. The other reason, I'm sure if we looked at population numbers, my guess would be that Las Vegas has been slightly increasing. And that's purely from the movement or the increase in populations of all the kind of areas kind of extending out from LA. And, there's a lot of people who travel back and forth between those two cities. My guess is the population has increased. I think another thing we haven't talked about that might be driving a little bit of that, and I think I mentioned this way back in like week 1 when we talked about potentially complementarities, but I think someone, I know one, maybe 2 people's project ideas related to this, but something that we might think is a complementarity with sports and has really taken off in the last few years has been sports gambling, right? And so maybe this idea, like all these sports gambling companies have become like a lot more legitimate and extending out to other states, and maybe there's some complementarity there that they believe exists. But off the top of my head, that's what I think probably would explain more of that movement. I don't know much about income trends in Las Vegas, but that could be playing a role as well.
I also feel like since it's such a touristic area and people with higher incomes tend to tour, like go to more like Vegas more often and for like tourism purposes.
Yeah.
People would be more willing to pay higher prices for tickets.
Maybe, but if I'm building a team, I'm probably thinking about what can build a. So you have to believe that someone is going to be a tourist and then want to go attend a Las Vegas Raiders game, right? So relying on tourism for your consumers and your demand curve is probably a lot less guaranteed than relying on a local fan base. But I mean, there could be I wouldn't completely rule that out, but I would think that maybe less likely. Were you going to say something earlier?
I was going to ask you, sports gambling kind of.
Yeah, and like I said, that would be the other kind of, and I know that I've heard like a couple of you, like I said, for your project ideas, and I've read some things on, there is this huge interest of when states legalize sports gambling, is there any type of complementarity to that and an interest in the game? So do you see increases in attendance? And there hasn't been a lot of research on it. And to be completely honest, a lot of it's because it's pretty new. Even like this last 2 months. So I'm from Michigan. Don't ask me why I know, but they just made it legal up there right before the Super Bowl. So, and I think Iowa was another state that within the last month or two. So a lot of these states just haven't adopted it yet, but that is definitely kind of a relationship that exists. Okay. All right, I like this. A little bit of an aside, but I like these conversations. So, I don't know if I'm going to go through this too much. I mean, this is like, this is just kind of an interesting thing about the new stadiums that we might see increases in utility from the individuals using it. So if we're not just thinking about this from the team's point of view, but more from like a social point of view, that these new facilities also potentially have this huge gain to consumers in that the utility derived from attending a game now is much, much higher. So they build like, retractable roofs, beer gardens, pools, rooftop terraces. I'm probably missing. There's a bunch of different things that they're doing now to try to make the experience basically have a higher utility for when you attend, which if there's a higher utility to individuals from attending, what will they be more likely to do? All right. Utility, kind of think about this marginal benefit, which is the demand curve. Demand curve increases in the ticket market, they'd be willing to pay higher prices. And then, I mean, there could be some consumer surplus lost if we were previously selling out stadiums, right? Then if we built a smaller stadium, if we went through, I'm not going to actually reproduce this, but you kind of think about, like from homework 1, if that capacity starts to move to the left more towards the kind of y-axis, what you're really doing there is you're cutting a lot of consumer surplus by that reduction in the number of tickets you sell, especially if you have the market is monopolized, which most of these ticket markets are. And so maybe there's some consumer surplus loss because the trend has been that a lot of these stadiums, they're building kind of lower capacities, right? And so everyone who would have bought a ticket before now is not able to. You're losing out on some consumer surplus from those individuals. All other things equal. But I don't want to waste too much time on this, but this is just kind of an interesting because we're not going to ask any questions on it. But another thing that we can think about is, different facilities will be built differently, right, to maximize the utility of the fans or the consumers based off of how the sport is played. So we think about facility shapes and sizes. if we go back far enough, a lot of these leagues, NFL teams, Major League Baseball teams, they'd share the same stadium. The shape of an NFL field is much different than the shape of a baseball diamond, right? First of all, I just said diamond, right? So there's very different kind of shapes. And the type of stadium you would want to optimize the fan experience would be different across these leagues. So as populations grew and that there was enough revenue being generated in these sports, you then started to see teams kind of move away from sharing stadiums. Specifically, I don't think there's any team, if I remember, I always feel I always don't want to misspeak, but I'm pretty sure, 99% sure, I don't think there's any more football and baseball teams that share a stadium. There were still a couple left in the late 90s, I think in early 2000s, but revenue being generated from these sports has moved high enough to where it now makes sense for them to kind of build their own facilities, not share facilities, and they build very different types of stadium, very different shapes, because the shapes of the playing field is different, right? Now, that's true in NFL and Major League Baseball, but the NHL and NBA, there's no difference really in the shape or even in the size of their playing field, right? I mean, the courts and their ice, but where they play. And so we still see NHL and NBA teams share a lot of stadiums, right? Because they both have the same optimal shape stadium, right? And they're both kind of doing similar attendance numbers. And so the size of the stadium, they kind of want to be similar as well. And so for a lot of them, we still see them sharing stadiums, because if I can cut my costs in half and I don't have to sacrifice anything in terms of I still have the optimal shape of a stadium, well, then sure, I'll cut my prices in half if I can make it work scheduling wise, right? Whereas if I'm an NFL or Major League Baseball team, yeah, I cut my costs in half, but how much revenue am I losing out on because that margin utility or the experience of the game isn't higher for the fans because this weird shape and the angles aren't right, So this just kind of plays out when we look at the differences in these leagues, right? We still see that NHL and NBA sharing, while the NFL and MLB have completely moved away from that. Okay. Any questions before we keep moving here? So I just want to kind of point this out because we will start talking about some other issues that are related to sharing stadiums in the future, and this kind of goes along with that conversation. Well, I don't know if I might pick up on this. Okay, this is the last thing I was going to say. We'll finish this out then before we talk about some of these papers. So I already mentioned this a little bit, right? I kind of jumped the gun earlier and said if we have these new facilities, if in any way they increase, right, the revenue we're making in that ticket market, that would increase the demand and marginal revenue curve in the win market and predict higher quality. Right? So if a component of ticket revenue is the age of the stadium, right, and that as I win more games, I'll see increases in revenue. But if I have an older stadium, so if age goes up here, my revenues then go down. And if that's the relationship we assume, and we have kind of these huge fixed costs that aren't a function of the number of wins or age, right? Once the stadium's built, the cost just is whatever it was. It doesn't matter how many wins or how many games I win moving forward, or the age of the stadium moving forward doesn't change what the original costs were. Okay? So if we think about what equation am I profit maximizing, well, it's really revenues minus the cost of a win, because there's no additional kind of cost. I guess maybe if we want to go out 200 years, the cost of upkeeping the stadium might be factored in. But at least in terms of a linear trend with the age of the stadium, that doesn't factor into my cost. So my cost will be a function of wins, and then my revenues will be a function of wins, but then inversely related with age, right? Well, when I try to maximize this equation, right, if I'm looking at marginal revenue and marginal cost, right, in respect to kind of the win, unless there's some interaction between wins and the age of the stadium, when I take a derivative of this, I need to actually, let me, I had a bullet point. Instead of mentioning, I want to actually write it out for you. So let's say I had, I'll give it a functional form for this to make sense. And I want to move this so we can see the equation. There we go. So let's say I had revenues were simply, I don't know, the number of wins times some value A, and then plus some impact on revenues that the age of the stadium would have. Okay? That's my functional form. I'm just going to keep it linear to make it easy. And then my costs, I'm going to have are some function of wins as well, right? So each additional kind of game I win is going to change my cost by some. I'm keeping it linear to keep it easy. And then we had these huge fixed costs, right? When I think about profit maximizing, if I take a derivative of this in respect to my wins, right? If I'm trying to choose the optimal number of wins to increase profits, if I take a derivative in respect to W here, so I think about this as all I would have would be A minus C. Right? And that's the most, it's pretty simple, but that would be kind of what I'd be left with. Whereas if there is any relationship between my team quality, right, the number of wins I'll get, and the age of my stadium because of the shift in the demand and marginal revenue curve in the win market, so that would mean that my functional form would look something like this, times age. I'll keep this here. But then there'd be this kind of interaction, right? That there was an additional effect coming from winning games depending on the age of my stadium, right? And then I have my costs, and I have my fixed costs, my marginal, my fixed costs, right? Well, now when I take a derivative of this equation, I'd have what? I'd have A, in respect to W, A minus D times, not minus, sorry, plus D times age, minus the cost, right? So now I have this additional, sorry. And actually, since we already have the equation, make it bigger too. So now, it's not, I have this additional component or this additional benefit that's going to come from wins that was related to the age of the stadium, right? If there's any interaction between the two. Right? So where the profit maximizing point is, could depend on whether or not I kind of have this new facility and I'm able to reduce age. Right? All right. And I'm not going to ask you to take derivative. I'm just kind of showing you kind of what's going on behind that thought process. So, there should be no impact if there's no interaction between the age of the stadium and wins. So there's a couple papers that kind of investigate whether or not there is this interaction, right? So Hakes and Clapp, they find no difference in revenue from wins for teams that have new versus old stadiums. So that they have a finding that there's no real relationship interaction between wins and age. And then Quinn et al. Also found kind of the same thing, right? There's not only is there no difference in revenue, but there's also no difference in kind of team quality that comes from having a new or old stadium. So we probably think the real functional form, it may not be linear, but we don't think that there's this interaction term that exists. We think it's probably something like this, so that a new facility really isn't changing the optimal wins of teams by very much. All right, so any questions before we kind of continue here? Last 15 minutes. So I want to introduce this idea of the hot hand. So I do this in, So I do this in my stats class, and I think a lot of stats professors probably talk about either the hot hand or the gambler's fallacy. Right, so there's a couple applications that we see to sport, and I'll talk through a couple papers, briefly give you an idea about some estimation equations for some linear regression, to kind of get a little bit of a discussion of that this week. Next week, I'm going to do a deep dive on a paper to kind of help you, maybe you've done it in other classes, but I'm going to kind of show you some tips and tricks to finding some for the literature review part of your project. So using Google Scholar along with some other tools. So we'll do a little more of a deep dive next week into that. But for this week, we'll focus on this hot hand and this gambler's fallacy idea. So the easiest way we can think about these two things is the hot hand fallacy is if I see something occur, I think it's more likely it continues to occur. So this would be the idea if I'm flipping a coin and I see it come up heads, I think, I go more extreme. Let's say I flip a coin, I see it come up heads 5 times, right? And I think, well, man, this is just like it's on a hot streak. It's got to keep going. So I think it's more likely it comes up heads on the 6th. That's the hot hand fallacy. The gambler's fallacy, because each coin flip is a 50-50 shot. The gambler's fallacy is if I see it come up heads 5 times in a row, well, I know over the long run, I'm going to get a 50-50 split. So after I see 5 heads in a row, I start to think, well, it's got to be tails in the 6th flip, right? So they're almost the exact opposite, right? If I start to see successes, right, a high number of consecutive successes, the hot hand fallacy thinks I'll continue to see these successes. The gambler's fallacy is that if I see a high number of consecutive successes, I start to think I now won't see that occur. So these events are independent either way, so it's always going to be 50-50. So these are the kind of, that's what we call them fallacies, right? It's an incorrect way of thinking. So, if I'm looking at a player, and, I use free throws here because that's what the paper gets at. But if they shoot 50% from the line, right, so it's equally as likely every time they take a free throw, it's equally as likely they'll make it or they'll miss it. Right? And I see that they've made 4 in a row. What's the probability of them making that 5th one? Still 50%, right? They're a 50, if on average they're a 50% free throw shooter, they're going to end up making half and missing half. So it doesn't matter how many successes I see in a row, the probability in that 5th is still 50-50. So, each one's independent, right? So 50-50. Right? Now, we could run into some issues here with the actual gameplay of basketball where, well, maybe if they make 1 at the end of the game, because they're down by 1 or they're down by 2 or 3, that they might try to brick it and so that they can win the game by getting the ball back quickly and shooting it too. But for the most part, this line of thinking is that they are independent. Okay? So we already talked about if this was the gambler's fallacy, we think that, because we've seen kind of 4 in a row, that it's got to equal out, so we'd be more likely to see him miss it. Hot hand fallacy would say, well, I've seen him make 4 in a row. They're hot, right? They got a hot hand, right? So they'll make that 5th one. Okay? So if we treat these as independent events, and I'll come back here to the estimation equation in a second. Well, no, I'll actually do this now. So we're thinking about trying to figure out whether or not there's a hot hand in basketball shooting. Like maybe it's not a fallacy. Maybe like once you're feeling a rhythm, there's some type of like muscle memory where you actually are more likely to make a 5th shot if you've made the previous 4 in a row. So the way that we're going to try to estimate for hot hands is we can think about, let's look at the current shot. So we'll call that time t, right? The shot that the player is currently taking. And the most simplistic linear regression equation we could use is we'll have some intercept and then the coefficient on did they make the previous shot. Okay? So if we had all of this shot data from the NBA, we could look and see if a player makes their previous shot, right? This is just a 1 or a 0. 1 if they make the shot, 0 if they don't. If this becomes a 1, right, a 1-unit increase, if they make the previous shot, here's the effect that has on the following shot. Now, if shots are truly independent, what should this coefficient be? Making the previous shot, what impact should that have on making the next shot if they're truly independent? Yeah, 0, right? Or we shouldn't see it be statistically significant, right? We assume it's 0, so basically, when we run this regression, we would expect that this won't be significant, right? It will be something probably close to 0. If we think that the hot hand exists, what should the sign of that coefficient be? Not necessarily 1. It could be 1, but it would be, yeah, positive, right? We would expect that there's some positive relationship, that when I make that previous shot, when that's a 1, there's some increase in the likelihood I make the next shot. Okay? And, I don't know, if we believe in the gambler's fallacy here, like, not in it, sorry, if the gambler's fallacy wasn't a fallacy, right? If a cold hand, per se, existed, then we would expect this to actually be less than 0, okay, negative. Oh. Okay. Does that kind of make sense? And so we could do this not just with like free throw shooting. You could do this with, hell, you could do this with bowling data, like see if you're more likely to get a strike if the previous bowl you had a strike. I haven't seen anybody do that actually, but that, I've seen, there's a couple papers, there was one that did it with horseshoe. I guess it's called horseshoe pitching, by the way. Like when you throw, I don't know how many of you are familiar with the game of horseshoes, but so you could do this with anything where you're looking for success or a failure, right? Making the basket or missing it. Okay. So that's what this paper did. They looked at 2 seasons of free throw data. They kind of ran this estimate, this linear regression to come up with estimates for the coefficients, right? Now, one thing that they did was every player is going to have a wildly different underlying field goal percentage, right? I don't know how familiar all of you are with the NBA, but like Shaquille O'Neal had a much worse free throw percentage than Michael Jordan, right? Or you can think about usually there are some poor shooters and there's some better shooters, right? So what they did was in this column, they ran this regression and found that's a pretty sizable effect. The hot hand may actually exist. It doesn't look like it's a fallacy, right? Well, then they included some player fixed effects, which is basically just accounting for whether or not, all these indicator variables for 1, if it was Michael Jordan, 0 if not, 1 if it was Larry Bird, 0 if not. So all those coefficients would pick up like the effect of being that player on free throws. And so once they accounted for who the player was and like what their underlying free throw percentage typically is, kind of cut that estimate in half, right? But they still found some evidence that maybe the hot hand does exist. Okay? And they did things like they broke it up by players who shoot more free throws than others. We won't kind of focus on this. And selfish or shameless self-promotion. But I don't know how many of you know who Professor Nesson is here or in the econ department, but we have a paper right now that's like trying to somewhat debunk this. And that one of the main things that we find is that even with free throw shooting, you need to account for a lot of other factors. And if you start to account for things like even the attendance in the stadium, you start to account for things like the time of the game it is, that actually this effect goes completely away. And we actually get that there is no hot hand that actually exists in NBA shooting, at least. Right? So, no, like I said, shameless self-promotion there. But you can also look at the hot hand and other things as well. So, where are we at in time? All right, I'll go through this one. So, question might be, instead of with basketball, is a player more likely to perform better at their current at-bat in baseball if they perform better in the previous at-bat? So now we're not thinking about consecutive shots, but we might think about it as like, does a player get a hit in this at-bat if they got a hit in the previous at-bat? And we could then extend this not just to hits, but maybe are they more likely to get a home run in the current at-bat if they got a home run in the previous at-bat? Or we could do bad things as well. Are they more likely to see a strikeout in the current at-bat if they had a strikeout in the previous at-bat? And we can see if there's any type of hot hands that exist that aren't actually fallacies, that they actually do exist. So this paper basically does that. Now they try to measure the state of the batter. So they do some goofy things where they don't just look at the previous at-bat. They actually look and say, okay, is it more likely I get a hit in the current at-bat if I've had success in the previous L at-bats? So they change this a lot in the paper. Sometimes they do in the previous 5 at-bats. They run the same regression. What was your performance in the previous 10 at-bats? And what they end up finding is, we're basically searching for, is this gamma, which is typically I write it as B or beta, but is this positive? So they run this kind of regression. And they kind of look at the state of the batter, and they're kind of finding positive amounts here. So maybe it is, more likely I get a hit in the current at bat if my previous state was kind of that I was seeing more successes in my previous 5 at bats, my previous 10 at bats. And they do a bunch of other stuff here that, we're not going to do a deep dive in this paper. I just pulled the table. But really the kind of main thing here is that they're finding these positive results. And notice 3 stars in each of them. They're all statistically significantly different from 0. So we're going to focus on those. And they did some stuff for pitchers as well. I didn't mention that, but they also do kind of whether or not I'm more likely to throw a strike on the previous pitch if I threw a strike in the previous, sorry, on the current pitch if I threw a strike in the previous one, or kind of I'm more likely to give up a hit in the current at bat if I gave up X number of hits in the previous 10 at bats. So there is some evidence that maybe these fallacies don't apply to kind of human or sports performance, that these events actually aren't independent. Now, whether or not that's from some physiological mechanism, or maybe it's just psychological, right? I have less stress after a success than I do a failure, or I'm not thinking as hard, or so whatever the mechanism is, it looks like it's not a fallacy, right? That they're actually may be more likely to see a success or a successful kind of human performance measure if they were previously successful as well. And that would, that is different circumstances, right? It could be shots, could be at bats, could be pitching performance, but we do see a lot of evidence that there is something going on there. I'll skip this because I don't want to focus too much on this today. I just had it in case we had time. So the other thing I want to mention before we get out of here that you can also apply this hot hand to is gambling behaviors in sports. Okay? So when they set these betting lines, I might have mentioned this in this class before, I can't remember. What a betting line should be when you bet like an over-under on a game, or you bet whether or not a team is going to win, they're trying to set the point differential of the game. So usually, say it was like a 10-point spread, then this one team is favored to win by 10 points, and the other team is favored to either, lose by 10 points or more. Right? Or sorry, it would be, lose by 10 points or more. 10 points or less. But the way they set that 10-point line is they try to make it a 50-50 bet. So they have a bunch of data. They run these regressions and come up with predictions that try to get that whatever number they've chosen. That's where there's a 50% chance that the score is wider than that, or a 50% chance that the score gap is less than that. Right? So every single game, right, they're setting these lines. They're all independent. Every bet should be a 50-50 probability. But when we look at people's behaviors, so this paper collected a bunch of data from these different legal bookies, essentially. But they look at the percent of people that bet on the home team to kind of cover that spread. And then, where is it? I don't think where is it here? Okay, here it was. So then they looked at different streaks, right? So has the home team kind of covered that spread in the previous one game, previous 2 games, previous 3 games? Kind of what they find is, where is this at? Why am I looking at this wrong? No, these are controls for quality. Sorry. Sorry. I'm thinking about the wrong paper. I might have accidentally put the wrong one on Canvas, actually. So the percent of people that bet in the home team should be kind of a 50-50. So when we look at that point spread, right? So if we look at the coefficient on that point spread, what this is predicting is that when someone's looking at kind of this team that previously covered that point spread, so in the game prior, they previously covered the spread, right? That people are actually less likely to bet on them to cover the spread the next week. So when it comes to betting, we actually see people falling kind of victim to that gambler's fallacy, where they think things have to kind of equal out, in the long run. So when they see a team kind of cover the spread previously, they're less likely to bet on them to cover the spread the next game. Now, why do people fall victim to the gambler's fallacy in some situations and the hot hand in others? That's, a mystery, right? Because they're both incorrect ways of thinking, and we tend to see in gambling, people can go either way. And it just so happens to be when we're looking at these point spreads, people tend to fall victim to that gambler's fallacy, even though every single betting line is set independently and should be a 50-50 bet. So we should be seeing that. It doesn't matter if the team covered the point spread in the game before, the effect on the current game should be 0, right? There should be no impact on the current game. So just some more evidence, kind of this idea of the hot hand and the gambler's fallacy. I wanted to talk through it a little bit. thinking about some different regression results and really just thinking about kind of some of these simple linear regressions we could run to get at these questions of, that are kind of an economic principle that overreaches just sporting examples, right? We could apply the hot hand or gambler's fallacy to a lot of different situations. But this is really the simple starting point of that equation. And then, of course, you want to add in a bunch of different control variables. All right. So before we get out of here, are there any questions for me related to anything as we kind of get out of here? Like I said, all of you should have a comment on your project proposal by the end of the day. All your homework grades should be up there. In the morning, I'll kind of repost that homework with a little bit of a curve to it, an announcement that accompanies it. You've got that second homework assignment you should be working on. If you start to work through that and you have questions, please feel free to reach out to me. Try to start working on that earlier rather than kind of later. Hopefully like early next week, I'll start to see some emails from some of you with questions. I want you all to kind of do as good as possible. Another thing I'll mention after completely grading, I know I'm over a minute here, so I'll get you out of here in just a second. But on those, even if you're not asked for a graph, there's usually some type of graph that you can draw that probably helps you get a lot more partial credit on that homework assignment than if you don't include anything. So that's one thing I noticed in that first homework assignment. Even if it doesn't ask you for a graph, there's probably something a graph that's related to that you could draw to help you answer the question, and more likely that you'll get to the correct answer, and also more likely you probably can get some partial credit even if your thinking is a little bit off, okay? All right, I'll let you guys get out of here. I will put an online quiz up over today. It should be really easy, and then I'll see you guys Tuesday. So have a good weekend.